also point out that the webinar is being recorded. So without further ado, I'll take just a few minutes to introduce the FAIR project and give a little bit of context and setting the scene, and then I'll hand over to Moran for the more substantial bit of the webinar. So FAIR, for those of you who are not familiar with the project, it's a big European project with a lot of partners throughout Europe, also representing different viewpoints, and it's really great to see all of those perspectives coming together. It came out of the Horizon 2020 Infra EOSC 5C call, a budget of about 10 million, and led by 6 core partners under the leadership of Dans, also within the Netherlands. The project just passed the halfway mark. We started March 1st, 2019, and a total of 3 years. And it's really great, yeah, again, like I said, to bring all these people together, because we all know that if we really want to make the European Open Science Cloud a success, we really need to come together and we really need to work together. And it's great to see that it's happening. So FAIR is really all around surveying the landscape of FAIR activities, but also driving convergence, bringing things together and create the basis of harmonization, as it is expressed here. Really a fruitful infrastructure, if you like, the fruitful groundwork to work together and build that FAIR ecosystem together within Europe, but also worldwide. Fortunately, we are not alone. We have a great high-level advisory committee. You see some of the names in here. And we also have a European group of FAIR champions who advise us within the project and give guidance when that is helpful. The main outputs or the deliverables of the FAIR project, they split into several categories. There's an area around data practices, an area around policy, an area around certification, and also training, education, and support. So really spreading quite wide. The work itself is organized into work packages. This slide here provides an overview. And just to give you a little bit of sense of where we are today, there's here work package 2, which is all around FAIR practices, semantics, interoperability, services, and software is implicit in there. Within work package 2, which is being led by CSC, my colleague Jessica Parland is our work package leader. Just highlighting a couple of reports and publications that came out this year. Pertaining to the fairness of services, of semantics, FAIR requirements for persistence and interoperability. And then in October this year, an assessment report on the fairness of software. And that is also the basis of the presentation today. I also wanted to do a very brief plug. We are working on a publication that's at the bottom here, a report on a basic framework on fairness of services, which is due the end of the month. So stay tuned for that report as well. I also wanted to say, to put things in context, I think for us a big how we think about progressing this harmonization around FAIR is really using the mental image of a FAIR data ecosystem, which is a space where digital objects, data, software, semantic artifacts, etc., come together with the services and the infrastructure that act on them. To really facilitate findability, accessibility, interoperability, and at the end of the day, most important, reuse. And there we see that we really need to work together to create a basis where the services and the digital objects really interact in the best way possible. This was also my takeaway from a recent webinar that I attended where Karel Luyben expressed it in this slide. I copied the slide from him. We're really talking about a web of FAIR research data and services, and it's not explicit in the slide, but very much in the way he spoke about that. It's not strictly about only data in the limited sense, but really all types of digital research objects, including software, very much on par with research data sets. With that, I would like to stop my general introduction and then give the floor to Moran to speak more about FAIR plus software. Moran, the floor is yours.
Thank you, Hilge. Thank you for this lovely introduction to the FAIR project and to our work on work package 2. And we are on task 2.4. I'm going to share my screen now. Just a moment. And you will tell me if that if it works. Can you see my screen?
Yeah, we can see your screen just fine, madam.
Thank you very much. So, hi everyone. My name is Moran Green-Peter. I'm based at the INRIA Research Center in Paris, France, on the software heritage team. I'm a software engineer and the metadata specialist for the Software Heritage Archive. And today I'm going to discuss with you this subject, very interesting subject about FAIR and software, and specifically our report that we've published a few weeks ago, decoding the principles. So let's see what we have for you today. First, I will introduce to you this assessment report. Afterwards, we will look at software, particularly software source code, as a forgotten pillar of research. Then we will survey the existing mechanism, components, and infrastructure. It won't be exhaustive, but to give you a window to what is out there that can make software fairer and maybe better. Then I will cross over to the FAIR side to introduce the FAIR ecosystem and some concepts from FAIR, from the FAIR principles, and where we stand with that. I will then do the literature analysis, which is described in the FAIRsFAIR report, with two specific examples from this analysis, but we won't go through all the guiding principles today. Lastly, I will present to you the 10 meta recommendations that we have produced in the report that are more about the high level recommendation about writing FAIR principles for software. So first, the introduction to the report. This report is now published on Zenodo. It's version 1.1 with a very interesting set of people who are all part of the FAIRsFAIR project. It was also reviewed by the steering committee of the FAIR for Research Software Working Group, on which I will detail a little bit more later. And it's now actually on open consultation, the community review. Today we will launch this community review with this webinar, and also we'll try to promote that on different platforms. So you can go over to the report but during this webinar, I will do my best to present what we have done with the report. So the goals for today is to review the different mechanism, components, and infrastructures that improve the fairness of software in the scholarly ecosystem, which are part of section 5 in the report. The analysis that I've said earlier, that's in section 3, and this 10 high-level recommendation for the future work to define FAIR principles for research software, which are available on section 6. To continue this this outline, I'm going to ask the first question, which is the more high-level question: what is software? What are we talking about when we say software? With this Encyclopedia Britannica definition, we have instructions that tell a computer what to do. Software comprises the entire set of program, procedure, and routines associated with the operation of a computer system. The term was coined to differentiate this instruction from hardware. Yet this definition, we don't see two main aspects of software. First, the fact that the software is also a concept or a project or even an entity on which we have a complete community around this project, and it embodies an idea or solutions which are not a digital object. And we have, on the other hand, the software artifacts, which can be fair or might be fair, that's the question, that can come in source code form or in binary form to be executed on different environments. Software is all around us. It's not new that it's all around us. And It started a few decades ago. We can see here Margaret Hamilton standing next to the entire printed version of the source code for the Apollo mission. And she's saying, when I first got into it, nobody knew what it was that we were doing. It was like the Wild West. Maybe having FAIR is a step forward to not being the Wild West. Then we have another example, which is actually the invention of the World Wide Web, which was a research project invented by Tim Berners-Lee while working at CERN. And another quote here is about the semantic web, which is not a separate web, but an extension of the current one, in which information is given a well-defined meaning, better enabling computers and people to work in cooperation. So why software? What's software? What do we think about software, and how do we see software? A small funny image I've got here for you is how people are used to see software. It's like a lot of magic, but it's actually an interconnection between logic and data. The source code embodies this logic, the logic of the data transformation. And we can see that software is something rather complex. It evolves over time. It can last decades. It might be full of the development history, which is part of the key to understanding it. It includes millions of lines of code and might have a large web of dependencies, which are easy to break and very difficult to maintain. And around the software, there can be sophisticated developer communities. So this, one of the things that software source code is special and not just data. So when we look at software, why do I say that software source code is special? Because the source code is this knowledge, is this logic that is captured in a readable text that you and I and everyone that doesn't necessarily write software can really read. Now, can this person comprehend? It's another matter, but the knowledge is in the source code. It is human readable, and it might be executed as an executable. So here I put for you two interesting quotes. One by Harold Abelson from 1985, that programs must be written for people to read and only incidentally for machines to execute. And the other one, source code provides a view into the mind of the designer, from 2006, from Len Shustek from the Computer History Museum. And on the other side of the slide, I show you a very small part of the Apollo 11 source code, where on line 72, there's a Latin phrase saying, "do not touch." And I'm quite sure that it will be very difficult to reproduce the source code today, but the knowledge is still captured and archived here on the Software Heritage Archive. So software and software source code are pillars of open science. As we can see for open science, we have open access repositories, open datasets repositories, and we need open source repositories. These three elements combined and the links to one another build our open science. To keep in mind also that software has different facets in research. It is not only a tool, but it is a tool. It might be a tool that almost every scientist or every researcher uses, but it is also a research outcome. It can be a research outcome when we talk about research software. It can be the result of a research process. And finally, it can be the object of research. What do we mean when we say the object of research? That the research is done on a large set of source code, for example, or on different software objects. We can have in mind kind of gaming or or game software on which can do some research, and using these games are not as a tool, but as the object of the research. Why are we here? So we have different needs, and maybe for these needs, the FAIR principles are adapted. But before addressing the FAIR principles, we need to see what are those needs in the research ecosystem. For researchers, we need to archive and reference software that is used and created in the articles. We need to find useful software. We need to get credit for developed software and verify, reproduce, or improve results. These are use cases that are needed for researchers. For laboratories and teams, we need to track software contribution, produce reports, and maintain web pages. And lastly, for research organization, we need to know the software assets that are linked to those organizations for technology transfer, impact metrics, or strategy. So it brings us to what do we have? So this is what these elements we need, and what do we have in the academic ecosystem that can answer the needs on one side and can answer the requirements for FAIR or fairer software. So continuing first with the landscape of existing mechanisms and components. Later I will do the infrastructure. I'm not going to go over all these mechanisms, but so you know they exist. First, for identification, we have extrinsic identifiers and intrinsic identifiers that are persistent identifiers that can be used for software. Furthermore, we have metadata, a very interesting landscape of metadata with one of the metadata vocabularies, which is we will see later on next slides. Then we have software licenses, and here SPDX is the software package data exchange standard, which is very interesting with its license list used in industry for open source software. Other subjects are software curation that exist already, and these mechanisms are in place and are described in the report, and the software artifact evaluation and badging that can be compared with FAIR. For software identification, the important question is, what target do we want to identify? We have here in this diagram, in green only, that's an image taken from the software source code identification working group output down below. If you see this DOI, that's from there. And in this report, we capture a great deal of the landscape of software identification. We see that identifying software isn't easy because we need first to know what do we want to identify. And there you have different granularity levels to see for which use case do you need which granularity level and which thing you want to identify. So if you want to identify the software concept or a software artifact, it's with a different identifier that you can do so. And that's a complex situation for software. Then the metadata landscape, we can see that is a very rich landscape between digital preservation vocabularies, linked data vocabularies, scholarly ecosystem vocabularies, and catalog and registries vocabularies. In the middle, we can see decode meta vocabulary, which is a bit linked to a few different categories. It's an extension for the software source code class by schema.org and has specific properties for research software. It's an academic community discussing software metadata, and there's also the crosswalk table mapping the metadata landscape. Also, you can find a code meta generator, which helps create this metadata file which can be contained in a GitHub or Git repository, not just a repository, in the code, in the source code itself, and document this metadata. So we see that these mechanisms exist. We have also the ACM take on reproducibility, because sometimes if you don't have the software, you just don't have the data. And when having the goal of reproducibility in mind, we see that there are badges that with a certain artifact review and evaluation can set if this is a reproducible experiment. We see that also there's still no consensus yet, and the term about reproducibility has just changed following the NISO taxonomy definition and recognition badging scheme working group here below. So after looking at this landscape of existing mechanisms and existing components, I'm going to briefly discuss the existing infrastructures, because to do FAIR, we need infrastructures that enable FAIR, like services that enable FAIR. That also the infrastructure should be aware of FAIR, but how they do so for software, and should they do so for software? That's also a question that will come in the next part when we discuss specifically FAIR plus software. Here, I've taken this diagram from the EOSC report. There's an EOSC report that is awaiting the EU Commission publication. There's a link to the document, but that's just a Google Drive document, to shortly say that there are 4 pillars for this infrastructure to have better software resources available on the scholarly ecosystem. And for that, they need to archive, reference, describe, and credit the software resources. For this report, there was a set of interesting contributors from these from aggregators, publishers, scholarly repositories, and from the Universal Software Archive that contributed to the document. And on our report, on the FAIRsFAIR report, we did also map and present the landscape of the existing infrastructure, synced to archives, publishers, registries, and research software training, which is a fundamental part in making the ecosystem fairer. I'm going to only discuss today the software heritage. It's a bit surprised me, this slide. So before I'm going to propose to you the slide on one of these infrastructures, we need to also have in mind infrastructures that are not from research, that are for software. Here, the version control system is an infrastructure that caters software, but not specifically research software, but all software. We can see the history of this version control system from the 80s, starting with local VC version control systems. Then in the 90s, with centralized version control systems, coming to Subversion in 2000, and then only in 2005, which is like very recent, we just have the distributed version control system with Git, Mercurial, and Basal. And Git is now very, very popular, and we might think that that's all, all we know and all there was, but it's not so. There's a long history before Git, and might we say that there will be things in the future or other version control systems in the future that we don't know about them yet. To add some information, a landmark is that the Software Heritage Universal Archive was officially launched in 2016. And in this archive, the idea is to capture all software source code from these different systems, these different version control systems. So for now, we do have different systems, and in a kind of a way that you can browse everything in the same way on the same archive and do the search on the same archive. In 2019, there was a mark of 90 million repository archived, but it was a year ago, and I haven't checked today what's the mark today. And to continue, the slide that I was prepared to present is the slide about the Software Heritage Archive, which aimed to collect, preserve, and share all software source code to enable better software and better research for all. To see how it works, there's an automatic pull from different forgers. The most important in sense of the greatest, the largest forge is GitHub, which is automatically pulled constantly. But you can also use the save code now mechanism with your Git repository link, and it will work on the archive to get your source code archived and referenced with an intrinsic identifier, the sweet persistent identifier. There are also mechanisms to deposit artifacts and to extract intrinsic metadata from the source code itself. And this is why we emphasize on putting the metadata in the source code. So this is the landscape of what's there, the mechanisms, the components, the context of software source code. And now we should continue to the main event of this webinar, which is the FAIR ecosystem and the FAIRsFAIR report. We wanted to build a bridge between software and FAIR, and thus first, after thinking about building this bridge, let's see what does it mean to have the 4 foundational principles and what we had in mind when we did the analysis in the report. So first, I might say that you might be all aware of FAIR and what the FAIR principles mean. We have on the left the 4 foundational principles: findable, accessible, interoperable, and reusable. And on the right, an image from the ANS website with a more specific approach about each one of the guiding principles, as you can see. But I'm not going to go through this image. I'm going to continue to our next slide to see where we stand about FAIR and software. In 2018, on the Turning FAIR into Reality report, the necessity to have FAIR also applied to software is written, but to tailor for specific context is also declared on Action 16.2. Then in 2019, or now 2020, there's the 6th recommendation for implementation of FAIR practice, where we need to recognize that FAIR guidelines will require translation for other digital objects and support such effort. Here, the emphasis for me is on the word translation. And also, or just in 2019, the opportunity note by the French National Committee for Open Science recommends that we must make sure that the specific nature of software is recognized and not considered as just data, particularly in the context of discussion about the notion of FAIR data. To do so, let's see where software is in the FAIR ecosystem. We've taken this really amazing figure from Laus and von Stein's report. Its original diagram can be found in this link. And we added this software icon everywhere that we can find FAIR. So we have FAIR where we can find software. So we have software in the box says software, but software is actually on other places. We have software in the digital object box, because as we said, that there can be software as research outcomes and software as the object of research. So that might be in the digital objects. Now, the whole system is kind of constructed with software, with repositories and services and even registries. All of that are implemented with software. So the question, when we look at a FAIR ecosystem, what do we mean when we say that we need FAIR software? Which part should be FAIR and which is out of scope of FAIR? What do we see on this kind of ecosystem? This brings us to our next point. I'm going to leave this question open because we didn't, so for the report, we draw the scope to FAIR, to research software outcomes and specifically source code. But this is an open question that should be asked when defining the FAIR principles for research software. What's the scope of FAIR on software object? Which objects should be FAIR and what should be done in this ecosystem? And in the literature analysis, we took upon a very analytic procedure, taking these 9 resources. It's a very full slide, and I'm sorry for that. I really don't like this type of slides, but it's really to capture what our intention by having these 9 resources and showing that these resources are diversified from different parts of the scholarly ecosystem. We have the Towards FAIR Principle for Research Software article from 2009. We have the 5 recommendations for FAIR software from the Netherlands eScience Center and Dance that's also published in 2009. The software citation principles, which they do not talk about FAIR, but the intention of software recognized in the scholarly ecosystem, that was important to include in this type of literature analysis, because not all resources are talking specifically about FAIR. That's from 2016. Then we have the RDA Software Source Code Interest Group activity from 2018, and though it's not written here. We have the From FAIR Research Data Toward FAIR and Open Research Software from 2020. Then we have Attributing and Referencing Research Software Best Practices and Outlook from INRIA. The Software versus Data in the Context of Citation, also from 2016. The oldest piece is the Science Code Manifesto from 2011, having some real pearl about software and what should be required for software artifacts, very similar to the FAIR principles. And lastly, we have the COSO, which is Comité Sciences Ouvertes, opportunity note encouraging a wider usage of software derived from research by the Committee for Open Sciences, Free Software and Open Source Project Group. And I hope with this slide I didn't lose you, because I will show you now the methodology we use this to analyze the FAIR principles. We have copied from each resource the exact text, not to lose its semantics, with these 4 key criteria in mind. Is this principle seen relevant, achievable, measurable, or benefits of it? What does it mean? Is it seen? So if we found on the resource that the resource acknowledged the relevance of the principle, we copied the text, and this meant that it was seen. Also, the same way we did with achievable, measurable, and benefit, seeing if this idea or logic behind the guiding principle can be applied to software. To show you just two small examples, I'm not starting with F. I'm starting with, and I'm only showing you two examples because it will be very boring to see all the examples, or this should be part of a workshop and not just a webinar. But just to have a small taste of what this means. It here, for example, AIR 1.1, which is in reusable. The principle is metadata are released with a clear, meta and data are released with a clear and accessible data usage license. You should note that we didn't look at each atomic measure. For example, we didn't look for are the metadata released with a clear and accessible data usage license and then the software, but just globally if this guiding principle was seen in the literature. And we see for this license, data usage license, which we of course looked about of copyright license and software license, this is a very relevant guiding principle for software and might be the only one for all the that was very high level with a large subset of 3 and plus papers in each of the criterias. I'm going to go a bit faster now, and I'm not going to read all the quotes, but I'm going to show you each one of the quotes that was copied into the analysis. And what is interesting is to see the wording from each one of these quotes and how it does show that literature think that principle is important. We can say this is kind of one example, and on the second example I'm going to show you, it's the interoperability principle 3, metadata and data include qualified references to other metadata and data. This is kind of difficult to apprehend when it comes to software, and here we saw that it's less shown. For example, here the first quote is not explicitly discussed, and then you have some other versions of what does it mean references to other metadata and data. Here should be linked to a list of publication using the code, to other version of the code, to relevant version of tools and library used, and to derived code. So this from the Science Code Manifesto, again from 2011, which is very similar to the ideas behind the FAIR principles. And so you can see that was not much discussed. But the interesting one is from the Towards FAIR Principles for Research Software, where I3 was discarded and created a new principles on their article. I4S software dependencies are documented and mechanism to access them exist, which is a newly proposed term. This analysis is very interesting to read and to really view the guiding principles, each guiding principles in the FAIRsFAIR report and how it was seen on those relevant resources. To conclude a little bit this analysis, and then I don't want to comment the entire compendium of FAIR software analysis. Hilke has nicely created pie charts to see how what's the impact on the complete total guiding principle. For here we have the relevant criteria, And we can see that there is high coverage of guiding principles that are relevant for software. If we continue and look at the achievable criteria, we see that the coverage is much lesser than for relevant. And there is a growing part of not available in the achievable criteria. Then with the measurable, it's completely not highly covered, as we've seen in the analysis. Well, not here today in the webinar, but we saw that it was very few literature pieces have come up with ways to measure the guiding principles or the ideas they were inferring to. Then for benefits, we see a much larger coverage for these guiding principles. So when we conclude the 4 criteria, these are the 4 criteria that we analyzed with the FAIR guiding principles and the 9 resources, where we see that the relevant is highly covered, yet not completely covered, not 100%. And the less covered is the measurability. Furthermore, we have captured in the report, and here on this very aggressive slide, beyond the FAIR principles, some items that are discussed in the resources that are not discussed in the FAIR principles, specifically the interoperability and the need of dependencies and execution environment. This is not discussed in the FAIR guiding principles, but is discussed in some of the literature, and should be a question if it should be included in the FAIR guiding principles for research software. Then uses of version control system to track changes. That's also not discussed in the guiding principles. It's about data. Well, maybe it should be also for data. As you saw, it is important for software to have a version control system. But yet, this is also a question. What's the scope of guiding principles for research software? We have the credit and attribution element that is discussed a lot, but is not part of the FAIR principles. And lastly, testing and software quality. Well, with this slide, we have also captured challenges that research encounter where they are trying to find relevant research software on the web and reuse relevant research software on the web. I think that it can really conclude the difficulties that people have today using software and writing software, and might not be answered with the FAIR principle as they are written today, and that this should be kept in mind. Lastly, we come to the last part of this presentation, which are for the 10 meta recommendations for writing the FAIR principles for research software. And for this, we use the RFC 2119. Each recommendation has a required level, must, which is an absolute requirement, should, which is a needed requirement for which exceptions are possible, and may, which is an optional requirement. It is important to acknowledge that any new principle may lead to extra requirements enforced on researchers who are already facing significant challenges when developing or maintaining software, which is a complex and living object, as you've seen on the first part of this webinar. And we need to be clear about the immediate benefits that should be offered to the researchers to maximize adoption. And with that, I'm going to read to you the 10 recommendations. Let's try to do that briefly. First, it must be take into account the specific nature of software. Applying principles and recommendations to software demands effort, time, and skill. So the realistic nature of these principles must be considered. Number 3, a large community forum must be consulted from different disciplines and with different roles. Recommendation number 4, existing infrastructure that already provide solution for software artifacts should be asked to review the FAIR principle for research software. Then, taking upon the criteria I've shown you from our analysis, each principle must be relevant for software source code. Each principle must be achievable for software source code. Each principle should be measurable. This is a should, because sometimes it's difficult to measure, and we saw that also it's difficult to conclude how to measure. And if it is measurable, it is a detailed explanation of how a measurable principle is measured must be available. And each principle should contribute to software recognition in scholarly communication and thus benefit software. Each principle should contribute to the curation quality of the software resource and not the quality of the software functionality. Each principle may solve one or more research software challenges that we have not specifically discussed today, but are elaborated in the FAIRsFAIR report. These recommendations had in mind specifically the FAIR for Research Software Working Group, which is a joint Force 11, RDA, and RISA working group with the main objective to define FAIR principle for research software as a community definition. The working group was just formed in April 2020 and launched with 4 subgroups in July 2020 and was recently endorsed by RDA in September. So it's just starting. You should join this working group if you are interested in FAIR and software to be part of the discussion. And for this working group, we have this steering committee written here, but we have also more than 140 participants on the RDA page. So to end this presentation, I invite you to get involved. So you might ask how to get involved. So first, participate in the community review of the FAIRsFAIR milestone with the assessment report on fairness of software and add comments on the shared document so we can have a better version with your input in it. Then join the FAIR for Research Software Working Group to receive updates, or more than that, contribute to the subgroup works and discuss the FAIR definition for research software. Then after that, you can also, or in parallel, adopt existing mechanisms and infrastructures that I've shown you today, for example, using a code meta the code meta vocabulary or a SWID or any other mechanisms that are offered today. Lastly, I will ask you to spread the word and let's together start recognizing software in academia. Thank you very much for joining us today. And I have a few minutes now. Sorry about this long presentation. We have 6 minutes to have some questions answered live. And I promise, as Hilke said, any question that isn't answered live, we will get in touch and answer this after the webinar.
Great. Thank you very much, Moran, for this overview. Any questions or comments, please? Maybe I can read it aloud to Moran. Maybe that's easier, then you can respond. We have a comment from Fotis. Excellent presentation, really useful overview. So thank you very much for that feedback. That's wonderful.
Thank you for this.
Any further feedback, questions, comments, issues?
I see there was an already answered question. Can we have a link to the talk email to participants? So yes, we will have the webinar video available, and also I will make sure that the presentation is also in PDF format available to the participants and to the public. So no worries about that.
All right, a last opportunity for any questions, any other comments? If not, let me wrap it up by saying that in the line of must, should, may, you must care about FAIR and software. You should read the report. The link is also provided in the chat. And you may engage in the discussion and give feedback. We would, of course, very much welcome any feedback that you have now or later. And let me close by thanking Morane once again for the great overview in the webinar. Thank you all very much for your time.
Thank you, Hilke. Thank you, everyone. Oh, there's a new question.
Do you still want to take that question, Morane? Sorry, that came exactly while we were closing down.
I can take that one. The question is, how close are we to FAIR software in practice? I would say that we are formally far, because we don't have yet the FAIR principles defined for software. So if we look at the FAIR principle as they are now, they are quite lightweight for software and relatively easy to implement for software. But the question is, do we want to go deeper into this rabbit hole with dependencies and environments and reproducibility? Because now the FAIR principles for software are not well, they're not the way to get reproducible software. They are, as themselves, getting better quality creation for software resources, but not for the holy grail of reproducibility. So I would say that that depends on what you take into account as the FAIR principles. If we look at the FAIR principles for data, I think we're not very far. If we want to, as we are defining the new FAIR principles for research software, the question is, will they be? And then if we are close to that in practice.
Excellent. And with those words, let's indeed close the webinar for today. We just have 1 minute left. Thanks again to Morane, and thanks to all of you. The recording will be made available, and if you want to talk more, please be in touch. Thank you.
Thank you, Hilke. Thank you all.